All right, here's our other starting small question, and this one has exclusions. We notice that the denominators have variables in them. So what we're going to do to find our exclusions is we are going to set the denominators equal to 0. So in this case, we have 2n equals 0. So we would divide by 2 to get n by itself, and 0 divided by 2 is 0. In this case, 5n equals 0. So if you divide by 5 in both cases, you get n is 0. So our exclusions for number 2 are just n can't be 0. So I know this says that it is, but an exclusion means to take it away, to take away that opportunity. So we want to say n can't be 0, because if n is 0, that makes the fraction undefined. So these are our exclusions. You don't have to write it twice. You can just write it once. Now that we have our exclusions taken care of, now we can go ahead and reduce. Single, 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 single. Again, they're single because there's no plus or minus signs. So what we're going to do is reduce any top with any bottom. It doesn't matter as long as they're identical or have a common factor. In this case, I see an n up here and I see an n down here. I also see an n over here. So it doesn't matter who you reduce the top n with, but you can only reduce one of them with one of them. So if you reduce this n, you can reduce this n, but that's it. You don't reduce both of them. You can only reduce one of them. Now I'm looking, and 9 has no common factor with 2 or 5, and 7 has no common factor with 2 or 5. So that means that we're done. These n's cancel and become 1s, because when they reduce, they become 1s. And now we're just multiplying across. We've got 9 times 1 times 7. That's 63. We've got 2 times 1 times 5n. So 2 times 1 is 2, and 2 times 5n is 10n. And this is my final answer.